Hello, I'm Mrs. Jacobson, and we're working on modules 10 and 11, and this group will deal with parabolas. So this first one says finding the vertex, intercepts, axis of symmetry of the graph of a parabola. So we notice the parabola is going down. Does the parabola open upward or down? Well, it opens down. That means that the a value in front of your squared term is a negative because it's going down. Find the intercept for both the x and y. So x-intercept, it's hitting the x-axis at 2. Y-intercept, it's hitting the y-axis at -4. Let's check if they want those as points. I always ask for points. Look at the bottom. They just want the number, so 2 and -4. So the x-intercept is 2 because it hits the x-axis at 2, and the y-intercept is a -4 because that's where it hits the y-intercept. The axis of symmetry is whatever your, oh, that's right, we didn't find the vertex. It's the line that goes through here, and your parabola can spin on it. And so in this case, it would be x equals 2. It is not always the intercept. But it is the line that goes straight through your parabola, and so in this case it would be x equals 2. Find the coordinates of the vertex. The vertex is here at 2, 0. And your x value on your vertex and your x on your symmetry will always match. Let's try one more. Let's try one going up. Maybe not. Okay, so this parabola is going up. Equation of symmetry. Find your vertex first. Notice the vertex is -4, -2. Your axis of symmetry comes from the vertex, and that's why I said to find it first. It's always x equals, and it's whatever the value is from the vertex. So it's x equals -4. The x-intercept is where it hits the x-axis, and notice there's 2. It hits at -2 and -6. The y is where it hits the y-axis, and it hits the y at 6. That's all that's to those. Domain and range. Domain and range of a quadratic function. Okay. The domain and range, remember domain is your x values and range is your y. The graph of the quadratic function with vertex 0, 2 is shown in the figure below. Right? Range and domain and interval notation. So they said range first, so we'll do range. Range is your y values. Notice these will keep going down. So it's -infinity up to 2. -infinity, and it stops at 2. It's including the 2. Infinity is always a parenthesis, but it is including the 2 because it doesn't have an open circle there. The domain is your x values, and this will keep going. It's going to get to these values. It's just taking a while. but it's going to cover all these values, negative infinity to positive infinity. We also know that's a quadratic equation, no fractions, no square roots, no logs, it's all real numbers. Try one more. A nicer one. Go up. There we go. So the domain of this one, well, what did they ask for? Oh, they asked for domain first this time. So the domain, this is going to keep going in both directions, this way and this way. So it will cover all of the x-axis, negative infinity to positive infinity. The range, though, notice the range, there's no negative values. The range starts at 4 and then goes up to infinity. So it's 4 to infinity. Including the 4, infinity always gets a parenthesis. Range, finding x and y, finding x-intercepts and vertex. Find the x-intercept and the vertex. We know y equals x squared minus 4x plus 4. And so we want to find the x-intercept. Remember, for the x-intercept, that's when y equals 0. So we're just solving the quadratic functions. And now you can, yes, this one is factorable. There's two numbers that when we multiply, we get 4, that when we add, we get negative 4. And that's a negative 2 times negative 2. Quadratic formula will always work, though, so if you're not finding what it factors to. But it factors into x minus 2 and x minus 2. When we set it equal to 0, we get 2. So our x-intercept is 2. The vertex, the x value is negative b over 2a. Where it's a is 1, b is a negative 4, and in this case, c is 4. Negative b over 2 times a, which is 4 over 2. To find the y value, we just plug it in. So we have 4 minus 8 plus 4 is 0. So our vertex is 2, 0. So the graph is at 2, 0, and the squared was positive, so it's going up. That's all it asked for. Oh, we didn't even have to graph it, but let's try one more. Because if you look at the vertex first, paper keeps. So we have y equal what? X squared plus 10x plus 25. If you find the vertex first, because depending on where it is, in this case, the vertex is x equals negative b over 2a. So x equals a negative 10 over 2 times 1, or negative 5. Now when we plug that in, y equals negative 5 squared plus 10 times negative 5 plus 25. This is 25 minus 50 plus 25, it's 0. So notice our vertex is negative 5, 0. Negative 5 is here, 0. Notice we already found our x-intercept, negative 5. They're both the same, because it's landing right here. See, so if you find your vertex first, like this one was not on the x-axis, and since it's going up, there are no x-intercepts. So you don't need to look for that. Over here, there's 2 of them. So by finding the vertex first and thinking about your graph, you know how many solutions there are. Let's try one more. Okay. These are all ending up. This one also ends up on the axis. Are they all? No, this one does not. Okay. Okay, let's try this one. So y equals x squared minus 4x minus 5. Now when we go to find the vertex first, x equals negative b over 2a. Negative times a negative 4 over 2 times 1 is 4 over 2, which is 2. That's your x value. You plug it into the equation to find the y value. 2 squared minus 4 times 2 plus 5. 4 minus 8 plus 5 is 1. So it's 1, x value is 2, and the y is 1, and that's your vertex. Now notice when we graph that, we would go over 2 and up 1. Oops. Over 2 and up 1, so it's here. The graph is going up because the x squared is positive. We're never going to hit the x-intercept, so there are not any. So always check the vertex first. No x-intercepts because it's not going down. If this were negative and it was going down, then you would have had 2 to look for, but in this case there was none. So always check for that. One more in this section. Finding max and min. Here it is. So finding the max and min of a quadratic function. When you're finding the max or min, think about the parabola and what it looks like. Depending on which way it goes, it has a high or a low point. When it's going downward, it has a high point. This is going to be a max. But when it's going the other way, it has a low point. This is a min. And remember, you decide by your a value. When a is greater than 0, it's here. And when it's less than 0, it goes down, so it has a max. So if we look at this first one, 2x squared minus 16x plus 29, the 2 is positive. Since the 2 is positive, the graph is going upward, which gives us a minimum. So it would have a minimum. Where does the minimum and maximum value occur? That's your vertex. negative b over 2a. And the b would be the negative 16. 2 times a was 2. 16 over 4 is 4. So it occurs at x equals 4. What's the function's max or min? That's the y value. So you just plug it in. 2 times 4 squared minus 16 times 4 plus 29. We're going to use a calculator for that one. 2 times 16 minus 16 times 4. And we get a negative 3. So there is a min of negative 3. Let's try another one. So this one is x squared minus 4x plus 8. Notice the x squared is positive. Positive means your graph's going up, which means, again, we're finding a minimum. To find that minimum, the x value is negative b over 2a, just like when we found our vertex. Negative b is negative times a negative 4 over 2 times a, which was 1, which reduces to 2. To find that, so that would be the x. To find the minimum, we plug that into the original. 2 squared minus 4 times 2 plus 8. 8 and 8 cancels and leaves 4. This is also your vertex. So you're finding the vertex also. It's the same process. Let's see if we could get a negative one. Because a lot of mistakes happen. I'll just make one up. We have y equals a negative x squared plus 3x minus 2. Let's do that. This parabola is negative, which means it's going down. That means we can find a maximum. To find the x value that gives you the maximum, negative b over 2a. Negative b is 4 over 2 times a is a negative 1, which gives us a positive 2. But when we plug that value in, the only thing being squared is the 2, not the negative. So this leaves a negative 4 plus 8 minus 2, which leaves us a positive 2. So we have a maximum of 2 at 2.